Hello. I have some students having some challenges with the systems of equations, and they are tricky. They are. Remember, you can always check your answers by putting each equation into Desmos. So I'm going to go ahead and do that. So that you can see. This is problem number 11 from our book on page 331. So if you put an x plus 2y equals 0, and then 2x minus 6y equals 5, we can see the intersection point. Right there it is, at 1 and negative 0.5. And I'm going to show you how to find that. Right here. Okay, so number 11, it's asking us to solve by the addition method. The addition method is the idea of adding the two equations together. Adding the equations by like terms. Meaning, if I were to add these two equations right now, I would have 3x, 2 and a minus 6 is a minus 4y equals 5. But all I did was add the equations. I didn't eliminate any of the variables. So I really can't do that. So we want to eliminate one of the variables. To eliminate one of the variables, we need them to be the same number but opposite signs. So to eliminate a variable, we need the coefficient. So the value on x, or for each of the values on x or y, whichever one you want to eliminate, they're called the coefficients, to be the same value but opposite signs. Okay. So I'm going to focus on 11 for right now. So if we want to eliminate x, we want to get 1, because if there's no number that you don't see, if there's not a number that you see as a coefficient, then assume it's 1. We have to get to a common multiple between 1 and 2. And so that common multiple is 2, which is nice because 2x is already there. So I want to get this row 1, I want this to be a negative 2x. So I want row 1 to be a negative 2x. So when I add row 1 plus row 2, remember how in the videos we labeled them row 1 and row 2? Row 1 and row 2. When I add them, oops, row 1 and row 2 down here. When I add them, they add to 0. The x values add to 0. Okay, so we're going to finish working on this problem. So to do that, I could, so notice that I could make x and the 2x coefficients any multiple of 2 as long as they add to 0. So I could say 4 times row, I'm going to just do a -2 times row 1. So when I do that, each of my terms, each of my pieces in row 1 get multiplied by -2. So this is going to be a -2x, because a -2 times 1x is a -2x, plus a -2 times 2y is a -4y, equals a -2 times 0, which is 0. Then row 2, I'm going to leave just as it is because it already has a +2. So notice I'm just going to leave that as 2x minus 6y equals 5. And notice when I do that and I add them, I add my x's and they add to 0. So my x's are eliminated. And then I have a -10y equals, this is just 0. So 0 plus 5 is 5. Then I can divide by 5 on both sides to solve for y. Oops, nope, I have to divide by a -10. Sorry, I'm going to divide by a -10. I'm dividing by -10 because I have to divide away what's attached to y. So y equals a -1/2. Okay. Then we're going to put y equals a -1/2 into row 1. It can go into either row, but I'm going to go into row 1. So x plus, I'm going back to the original row 1, x plus 2 times y. We said y is a -1/2 equals 0. So x plus 2 times a -1/2 is a -2/2 equals 0. So that's the same as x minus 1 equals 0. Make sure you're using your decimals to do this. -2/2 is a -1. And then to solve for x, I'm adding 1. Okay. So the point 1 and -1/2 is a solution. Okay, and how I can check that, so you need to be able to check your answers. How I can check that is I can put 1 and a -1/2 not back into row 1. That's what I use to solve it. I'm going to use the other equation. So into row 2. So that means 2 times x is 1 minus 6 times y is a -1/2. And I want to make sure that equals 5. So this is my row 2. Row 2 originally was 2x minus 6y equals 5. So I put in my x that I think is true, which is 1, and my y, which is a -1/2. And I'm just going to simplify to verify that this makes a true statement. So does it make a true statement? Question mark. Okay. So 2 minus, oh, but it becomes a plus because a -6 times a -1/2 is a +3 equals 5. And yes, it equals 5. Yay. Now let's look at the same problem to see how I could have eliminated the y variable. So if I wanted to eliminate y, when I originally added these, I would get a -4. So that's not going to eliminate. But I can see that I can get 2 to a multiple of 6 is a multiple of 2. So if I multiply 2 times a 3, I get 2 times 3 is 6. 6 plus a -6 will add to 0. So I could multiply row 1 by a +3 to eliminate y. So let's try that. Let's multiply 3 times row 1. So I'm going to have 3 times 1x plus 3 times 2y equals 3 times 0. So this is 3x plus 6y equals 0 once I simplify. Then I'm going to leave row 2 the same this time. So this is a 2x minus 6y equals 5. Notice by multiplying row 1 by 3, I now have 6y and minus 6y. So those, when I add them, those like terms add to 0. And so I end up with 5x equals 5 when I add the two rows, the two equations together. Then dividing by 5, I get x equal to 1. And then I can put back into row 1 if I want to. So 1 times x equals 1 plus 2y equals 0. So 1 plus 2y equals 0. If we subtract 1 from both sides, I'm trying to solve for y. And then I'm going to divide by 2, y equals a negative 1/2. So again, my solution is the same, 1 and negative 1/2. Okay. So you have to get the coefficients on the x's to be the same number but opposite signs, or the y's to be the same number but opposite signs. So let's look at number 15. I'm going to look at what multiples could we do to eliminate x is the question. So that means multiples of 6 and 9. Okay, so 12 will not work because 12 is a multiple of 6, but 12 is not a multiple of 9. So we could do we could say so you could make a table and find out what one is going to be. So let's look at the multiples so you can see how this is. So if I do 6 times 1, I get 6. 9 times 1 is 9. So that's not going to work, the multiple of 1. 6 times 2 is going to give me 12. And 2 times 9 is going to give me 18. And then 3 times 6 is 18. Okay, so they can both get to 18. So that's what we're looking for. You can also, we could say 3 times 9 is 27. 4 times 6 is 24. 4 times 9 is 36. 5 times 6 is 30. 5 times 9 is 45. 6 times 6 is 36. So we could do 36. So you're looking up for multiples that you can get them both to. So if I want to do 18, this is going to be my row 1 because 6 is my coefficient for row 1. So I would have to multiply row 1 times 3 to get to 18. So I could do 3 times row 1. And then to get 9 in row 2 to 18, I would have to multiply by 2 because it's 2 times 9 is 18. And now because they were both originally positive, one has to be negative. So we would do negative 2 times row 1. Or I'm sorry, negative 2 times row 2. So if we do 3 times row 1, we would get 3 times 6 is 18x plus 9y equals a negative 3. Remember, we're multiplying the entire row by 3. And then if I multiply the entire second row by a negative 2, I get a negative 18x minus 10y equals a negative 2. And just like we wanted, our x's add to 0. And then we have 9 minus 10 is a negative 1y equals a negative 5. And dividing by a negative 1, we get y equals a positive 5. So then we could put that back into row 1 to solve for x then. So 6x plus 3y, y is 5, so it's going to be 3 times 5 equals a negative 1, and we're solving for x. So 6x plus 15 equals a negative 1. And then notice I'm circling the variable that I'm solving for. That is a habit that is really good to have. So if you subtract 15, we get 6x equals a negative 16. And then we're going to divide by 6. We get x equals a negative 16 over 6. And we can turn that into a negative 2.67. But remember, because it's not a terminating decimal, I would not leave it like that. I would just leave it as negative 16 over 6. That's the most ideal. Now, let's say we wanted to eliminate y for number 15. We have to get y to a common multiple. Now, a multiple that always works is if you just multiply them together. So 3 times 5 is 15. And so that means to get to 15 for row 1, we would have to multiply that by the 5. So we would do 5 times row 1. And then because we want them to be opposite signs and they're both positive, row 2 needs to be the negative. So to get row 2 to be a negative 15, we have to multiply by a negative 3. So multiplying 5 times row 1, we would get 30x plus 15y equals a negative 5. And then multiplying row 2 by a negative 3, we get a negative 27x minus 15y equals a negative 3. And just like we wanted, our y's cancel. So we have 30x minus 27x is 3x equals a negative 8. And so dividing by 3, we get negative 8/3, which is exactly what we had gotten before. A negative 16 over 6, if you divide by 2, it's a negative 8/3 as well. And then we would go back and solve for y. So the key is to get to a common multiple. What do you need to multiply by to get them to a common multiple to add to 0? So let me know if you need any more help with solving systems of equations.